Welcome to the HMAR Mobile Tech channel, and today I'm working on a rear parking electric parking brake actuator control motor type circuit. Let's get started. First thing you want to do, if you're going to do any testing on any electrical components on your vehicle, you want to make sure that the battery voltage is totally pretty close to 12.5, 12.6 volts, somewhere in the ballpark. I've got a jumper battery box because I've been doing some testing here to prepare myself for this video. And so that's our first step here. And then, so I'll come back to the ignition on, and then turning the ignition off, and then unplugging the actuator connector and having it back probed and connected to the digital multimeter. This is the reading. So this is our bias voltage reading when the modules and everything were awake, and it's still awake. And then as we wait a little bit, it'll power down, and then it'll go back to that 2.5 to 3 millivolt reading, which is what we've been seeing most of this time. So the bias voltage when the module is awake was around 8 volts. Now when it goes to rest, it's going to go down to a lower 2.5 to 3 millivolt reading. And what this tells us is that the module is capable of powering up. The module is capable of going to sleep. And this is with the connector plugged into the actuator. And these next tests are going to be for it plugged in, what our volts reading just sitting here with the key off, engine off, and then the key on, engine off with everything plugged in normally. This would be our plugged in complete circuit bias voltage. With the actuator plugged back in and everything the way that it should be normally, back probed with my digital multimeter, this is the reading at rest with the key off, engine off, and everything gone to sleep. So this is the reading here is 0.5 millivolts. So 500 millivolts. That's with everything plugged in. Just like that. Now it's to the ignition in the on position. So you can see here that our bias voltage is switching a little bit from between 500 millivolts to 700 millivolts. So this is further testing your circuit integrity on this circuit here. I'm going to do an ohms test on just the motor itself. So I'll set up my scanner here. I'm going to go to ohms. And then what I'm going to do is I'm going to use my test leads, and with the connector, the harness side connector unplugged, I'm going to go right to the motor. So I'm going to, those two pins that are sticking out of the motor are male pins, and I'm going to go ahead and touch them. And it doesn't matter which way you hook it up because it's not polarity sensitive. You could put it in the lowest ohms scale if you want to do that. So let's see what our reading is. Let's put it to auto and see what it is then. So 0.6, so basically a half an ohm. This is what we learned in doing this rear parking brake actuator. These are the bias voltage that the results we got from doing all these tests. Number one, the actuator unplugged, key off, engine off. We had 3 millivolts DC. The system was at rest, meaning that everything was powered down and had been windows were up and doors were locked, everything like that. So that's system at rest. And then 2 was the actuator was unplugged, key off, engine off, 8 to 8.31 volts, not millivolts, volts DC. The module was awake, so I just turned everything on and then turned everything off, and then went back and did my test with the connector unplugged. So 3, the actuator plugged in, key on, engine off, was 0.5 millivolts DC. And then when the key was on, it was around 700 millivolts, so 0.7. So if you get number 1 and number 2 results, then what that tells you is that the logics and the integrity of your circuit all the way up to the module is good. If the connector's in good condition, no corrosion and all that. 3 and 4 are for if the actuator is in good condition. So basically, if you're seeing all this here when you're doing any of your testing, then you can be pretty confident that you don't have a problem with that particular circuit. And then you could take these readings and comparatively test to the other side. If you were doing testing on a known good circuit for the rear parking brake, electric parking brake actuator, like I did in this video, then if you have a good full service, full level scan tool, like I'm using my MS905 Autel Mini scanner here, you want to make sure you go into the module and you want to make sure that you didn't set off any fault codes doing all this testing. And I keep calling it module because I don't know exactly what module it's going to be. So now I'm going to find out. And so I'm going to log into Toyota here. I want to do a auto scan of everything. So as you can see there, it's in the brake EPB module. So it does have a dedicated brake module. It's 100% complete now, so I can go into the brake module here and take a look at what's going on. So as you can see here, this ECU controls ABS, vehicle stability, electronic parking brakes. So it does quite a few things here within this one module. So I'm going to have a look at the trouble codes. And then left is the one I was working on. The circuit is open, probably because I had it disconnected so many times. So I'm going to go ahead and clear that. And if you're doing diagnostic work and you've actually got a fault, then you want to write down that code or take a picture of it with your phone before you erase it. And then what you want to do is you want to go back and rescan to make sure you got everything. So I don't want to do them all over again, so I'm just going to go back, and I'm going to go back and I'm going to go just a control unit, and I'm going to go to brake EPB. Okay, so I have no fault codes. So I feel confident, I feel good, everything's all back together, everything's good to go. And this is my wife's car, so I don't want her screaming at me for doing testing on it and causing a problem when there wasn't actually a problem. This concludes my video today on this 2019 Toyota RAV4 checking the rear electric parking brake actuator and doing circuit integrity tests and bias voltage testing. And hope my video made sense. Hope you learned something. Hope that maybe you can apply this the next time you find yourself in this type of diagnostic situation. You did a good job. Thank you for watching. I'll see you next time.